Hey, PChem, let's practice with some Lewis structures since we didn't get a lot of time to work on it the other day. The first one we're going to start with is carbon disulfide. We're going to go ahead and figure out how many electrons we have in the bucket. Carbon is in group 14. There are 4 valence electrons. Sulfur is in group 16, so it has 6 valence electrons, and there are 2 of them. And so we have 12 and 4 to make 16 total valence electrons. We're going to put carbon in the middle. Remember, carbon goes in the middle, or we go ahead and we make things symmetrical. So we use 2 4 electrons to make bonds. We have 16, so we're going to go around and put our electrons around each. So 2 4 6 8 10, we're at 10 now, 12 14 and 16. Okay, so we've used all of our electrons, but the problem is each of the sulfurs is feeling a full octet, but the carbon is not. So one thing you need to do is take one of those electron pairs and you need to swing it into the middle. Okay, so we're going to make that a double bond. So now we have 2 4 6 8. That left carbon is still fine. But again, our carbon, our carbon is not feeling its full 8. So if we go ahead and fix that sulfur and swing those electrons in, now we have 2 4 6 8 10 12 14 16. So we have 16 electrons and a complete Lewis structure. Let's move on to nitric acid. Okay, so nitric acid. So we're going to go ahead and figure out how many total electrons we have to put in our bucket. So 1 valence for hydrogen. Nitrogen is in group 15, and so it has 5 valence electrons. Oxygen's in group 16, so it has 6, but there are 3 of them. So we have 18, 5, and 1. So we have 24 total valence electrons to work with. Now, this one's a little bit more complicated to know how to put our atoms, but we're going to arrange it so our nitrogen is in the middle. So we're going to have a nitrogen attached to an oxygen, 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 and then we're going to have the hydrogen coming off of one of the oxygens. Okay, so it's a little different than what you would have expected. So we're going to go, and we've used 2 4 6 8 10 12 14 16 18 20 22 24. Okay, notice the hydrogen has its duet of 2 electrons. The oxygen on the left has 2 4 6 8. The one on the top has 8, the one on the bottom has 8, but this nitrogen is missing a set of electrons. And so what we need to do is we need to take our electrons and we need to pull some in. So if we take these electrons and we pull them into a double bond, then we have our 24 electrons, and you notice that we have our double bond. All right, so one thing you might notice if you take a look at this is why couldn't that double bond be up here? Okay, and there's no reason. And what this is called is resonance. Resonance is when our pi bonds, so our double or our triple bonds, can move to another location and still have an equivalent Lewis structure. Okay, and so that's what we're seeing here, that we could have that in a different area. So let's go ahead and do an example of resonance. So we're going to do the nitrite ion. Okay, I don't know if I've shown you ions. And so when you have ions, the charge is telling you that there are extra electrons. So we have nitrogen, 5 valence electrons, Oxygen has 6 valence electrons. There are 2 of them. And so if we add them together, we would have 17 valence electrons, which you already know is a problem because we can't have an odd number of valence electrons when everything needs to be in pairs. So this negative right here is actually going to add an extra electron to give us 18. So if we had a positive charge, we would take 1 electron away. If we have a negative charge, so an anion, we're going to add an electron because it says that overall it has 1 extra electron. So we are going to go ahead and attach our oxygens, and then we're going to distribute the electrons. Okay, so again, we have 2, 4, 6, 8, 10, 12, 14, 16, and 18. So our left oxygen has an octet, our right oxygen has an octet, our nitrogen only has 6 electrons. So again, we need to get rid of one of these pairs of electrons. Okay, and so we're going to swing it in. And when we swing it in, our nitrogen now has 8. Our oxygen on the right has 8. Our oxygen on the left has 8. To go ahead and write out a Lewis structure of an ion, you should put brackets and the charge. That way you know where that extra electron or 2 is coming from. So to really illustrate resonance, what you should do is you should draw both structures. Or sometimes it's more. Okay, because again, resonance is showing us 2 different structures that are possible. So you would do a double-sided arrow and show those 2 different structures. What you'll notice is that the actual structure is something in between those. And so when they have actually measured the bond length, what they notice for the nitrite ion is that there isn't a single bond and a double bond. What there is are 2 bonds that are the same length. So we have a single bond and we have a double bond. But what the actual molecule has is not one of each, but something halfway in between. So it has let's call it a 1.5 bond. Okay, so if this is a 1 bond and this is a 2 bond, then it has a 1.5 bond. It has something in between. And so what you find out is that, again, the bonds are actually not 2 individual single and double bonds, but this set of electrons is flipping back and forth on each of these, and it flips back and forth so often that the bonds to the oxygens are a hybrid of a single and a double bond. Okay, and again, this was an example of both resonance. Resonance is when that bond moves back and forth, and an ion. Okay, I hope that helps.